So today we're going to be talking about a topic that I view is one of, if not the most important topic in regards to your future science courses. As a matter of fact, I heard Mr. Woodruff talking to, can't remember if it was his AP Physics or AP Chemistry class recently about this very topic, using the same kind of language you're going to hear me using today. As far as our book goes, they kind of have pulled this out from one edition to the other. So you're going to notice I am going to be supplementing with the old textbook as far as practice problems. It is not in our textbook, so you're going to need to use this video for your instructional purposes. So basically what we're going to be doing is transforming formulas. We're going to solve formulas for different variables. So if you kind of notice the formulas up here, we are basically going to take a formula and solve it. So in case up here, solve it for M instead of E, leaving all the other variables in rather than substituting data in first and then solving algebraically. We're going to do the algebra on the formula. So first of all, a formula shows a relationship between two or more variables. Just to jump down to the bottom, literal equation is basically a synonym for formula. It's just the mathematical way of describing a formula. It's an equation involving two or more variables either way. And the only reason I mention that is in case in the future you have a book that talks about transforming literal equations. A literal equation is just a formula. So speaking of formulas, let's take a look at a few. We just recently worked last week on perimeters of rectangles. So remember that the perimeter of a rectangle would be you need to add the two lengths and the two W's. Remember me talking about the number one mistake is people will forget to put the two and just have length plus width, right? So that is a formula. That is a literal equation. It is solved for perimeter. What if we wanted to solve it for width? We wanted the W by itself. So we're going to do algebra steps on the formula. That's what we're working on today. Do you remember the equation, or the formula rather, for circumference of a circle? Now, first of all, the word circumference, what does that mean in terms of other shapes? Or what would be another word that we could think of that would replace circumference? Well, actually, it would be that idea of a perimeter. Just with a circle, we don't call it a perimeter, we call it circumference. It's the distance around the circle. Do you remember that formula from your past? Let's see if you got it. C equals, the circumference equals twice pi times the radius. Remember that radius is the distance from the center of the circle to a point on the circle. And remember pi is our 3.14, and it goes on forever. It doesn't repeat. It doesn't terminate. It's an irrational number. Usually when you're talking about some kind of geometric formula and you see a pi in there, there's a circular component to it. We'll be talking more about that in a couple of minutes. So that's another formula. What if we wanted to solve it for radius? We wanted the R by itself. That's what we're working on today. How about force? Do you remember the formula in science for force? Did you think F equals ma, mass times acceleration? And again, what if we wanted to solve it for mass? What if we wanted the m variable by itself? And finally, converting Fahrenheit to Celsius. That one's a little bit harder to remember. We will be working with that one in a second. But basically, your Celsius temperature equals 5/9 times the Fahrenheit temperature minus 32. And you notice that 32, of course, is the temperature that water freezes. Fahrenheit is 32 degrees, and Celsius, that would be 0 degrees Celsius. So anyway, to solve a formula for a specific variable is to have the specified variable, the one that you're looking for, by itself on one side of the equation. So right now, this formula for Fahrenheit to Celsius is solved for Celsius. If we wanted to solve it for Fahrenheit, we would want the F by itself. And we're going to do that one in a couple of minutes. So let's just start with our circumference of a circle. You transform a formula by solving it for the different variables. So in this case, we're going to solve it for the R. So we want the R by itself, and we want this 2 pi to go to the opposite side. And remember, in equation solving, When we want something to go to the opposite side, we do opposite operations. So you're going to use the same rules, except this time you're going to be potentially moving things that are variables, not just numbers. So you're going to maintain the balance. Whatever you do to one side of the equation, you have to do to the other. And of course, you're going to show those steps. So now to get the r by itself, I need to kind of lose this 2 and this pi, which this is all being multiplied. Remember that it's 2 times pi times r. You might be tempted right now to kind of, well, the opposite of multiplying by 2 would be to divide by 2, and then also to take a second step and divide by pi. But because this is a product, you actually can do it in one step. And I often find that if students do it in 2 steps, not only is it inefficient, they do it incorrectly, and they end up with this complex fraction that has a numerator and then a denominator and then another number divided. So we're really going to just realize that we can divide both sides by 2 pi in one step. It is 2 pi times r. So in order to solve this for r, I just divide both sides by 2 pi. Now on the right-hand side, the 2 pi over 2 pi is 1r. That's what we wanted. And the left-hand side is that the circumference divided by twice pi will give you the radius. So now if for some reason I had a bunch of different circles with a bunch of different circumferences, I could put the circumference in, divide by 2 pi, I got the radius. Put the different circumference in, divide by 2 pi, I've got the radius. So I've solved the formula so that I can just very quickly keep entering different circumferences to get the radius, rather than put the circumference in up here and then, okay, now I got to divide and do the formula, divide by 2 pi. So you do the formula first, and it makes it easier for data entry. So here is the other one I mentioned a minute ago, solving this guy for Fahrenheit this time. So this is the formula that if you have a Fahrenheit temperature, let's say it's 65 degrees, you would input the 65, subtract 32, multiply by 5/9, and you get the Celsius temperature. But what if you have a Celsius temperature, like 10 degrees Celsius? If you put that in, you've got to do all the algebra steps to solve for F. So what we're going to do is we're going to solve for the F first, and then we can just put a bunch of Celsius temperatures into that transformed formula. So we're going to solve to get the F by itself. Now you're going to, be so trained on distributive property right now that you're going to be tempted to multiply in the 5/9, and I'm going to yell, stop, no. Because what you're doing is, notice that the F already's coefficient is 1. By multiplying it by 5/9, you're kind of already complicating what you have to do here, and you're going to have to undo it later. So instead, the best first step would be to multiply both sides by the reciprocal of this. Multiply the right by 9/5, multiply the left by 9/5, and that will start by taking care of that fraction. So that's kind of what I'm mentioning to do. So this 9/5, whether you write it at the end or at the front, basically you're going to get 45/45, which is 1. It cancels out this fraction. And meanwhile, on the other side, I do have, the 9/5 C. Notice these parentheses are no longer needed. I just left them there because they were up here. The only number out in front is 1. So now, to get rid of this minus 32, I add 32 to both sides. Oops, I just took the parentheses off there. Add 32 to both sides. And this is the formula to transform, to change a Celsius temperature to a Fahrenheit. So if it is 10 degrees Celsius, you would take 10 times 9, divide it by 5, add 32, and that's your Fahrenheit temperature. Oh, no, I'm sorry. It wasn't 10 degrees. I wanted 20 degrees. Oh, that's easy. 9 times 20, divide it by 5, add 32. So you could just keep putting in multiple Celsius temperatures and very quickly change them to Fahrenheit. You have to be a little bit careful. So this formula means nothing in the real world. I'm just made it up to show you something that students often kind of make a mistake with. But you got to be careful when you multiply or divide both sides of an equation by a number. Every term must be multiplied or divided. So let me just show you that with this made up formula. So let's say we want to solve this formula for y. Okay. The first thing that I just want you to think about this for a second. If you're getting confused with all the variables, just forget him over there. But think about this as, what if this had been the number, say 32? What if it had been 32 minus 2y? The first thing you would have done would be to subtract the 32 from both sides. So guess what? You're going to subtract the 3x from both sides. That's going to make a zero pair on the left. And over here, these aren't like terms, so they're simply going to stay apart. Are you with me? Now, here is what I'm kind of warning you about. In order to, again, get our eye on the y here and get rid of multiplying by -2, and be careful, a common mistake is to kind of lose that. That is the arm of the 2. It is a -2. Remember that a minus is the same thing as adding a negative, so this is negative. So we are going to divide both sides by -2, but make sure you divide everybody by -2. It's going to create a 1 in front of the y, which gives us 1y. We won't write it, but it will be implied. 6 divided by -2, we can simplify. That would be a -3. And we've got a negative divided by a negative, and we can rewrite that as a positive. So that is the same formula as up above, but solved for y. Okay, let's do a couple more real ones here. I am going to do, the next one is another made up one, but before we get to that, let's do the formula for the area of a trapezoid. Remember that a trapezoid is a 4-sided figure with one pair of parallel sides, the other sides not being parallel. And I don't know if you remember the formula for finding the area of a trapezoid. I'm going to just pause for a second and see if you can find that in the back of your brain somewhere. So the area of a trapezoid is that you're going to add the two bases. These are called bases. There's a longer and a shorter one. So you add the bases, then you're going to multiply by the height, and then you have to divide that by 2 or multiply by 1/2. So that is what the formula of a trapezoid is. I had a student a long time ago that came up with sort of this little rhyme, said, sum the bases times the height, take a half, fight, fight, fight. I don't know. It's stuck in my head, so maybe it'll stick in yours. I don't know. That's the area of a trapezoid. So right now it is solved for area. If you're given the area, the height, and the length now of the longer base, find the shorter base. So we need to solve for B2. See them right here? We want to solve this one for B2. Now, the first thing you're going to be tempted, again, is to kind of do this idea of multiplying and doing the distributive property. But when you do that, you're going to complicate the coefficient of the B2. It's already 1. So what we actually want to do is, can we move this? Can we get rid of this 1/2? I'd start by saying, how about if we multiply both sides by 2? If we multiply both sides by 2, then that 1/2 times 2 is going to be 1. And we are going to start by simplifying and getting rid of that fraction. I mean, come on, that looks better already. Now, once again, this whole thing is being multiplied by h. And I'm trying to release, I'm trying to free this B2. So instead of doing the distributive property, I'm going to divide both sides by h. So when I divide by h, then I would have a 1 here again. And I'm simplifying this side. And yes, this side's getting more complicated. That's what's going to happen. Okay, final thing. I want to free the B2, so I've got to get rid of the longer base, and I'm going to subtract. The opposite of adding would be to subtract it. So twice the area divided by the height, subtract the longer base, believe it or not, and that will give you the shorter base. So if you had the area of a trapezoid, you divide it by its height, you subtract the longer base, it'll give you the shorter base. Now, is there an application for this in the real world? I'm not exactly sure. I think the temperature one was pretty clear that it was nice to have it both ways. But just trying to take some real formulas that you have seen before and show you the process. So the mistake often on this one, it's not a mistake, but is to do the distributive property and get caught in a big mess. So I'm just trying to show you the easiest way to do it. In a minute, I will do one both ways for you, just to show you. Okay, so this is a really, really, really important slide. So attention, everybody. A very common mistake is made with this one. As a matter of fact, a science teacher at the high school, and does not share the same name, so it was my husband, pulled me aside once at an open house for one of my kids and was complaining how kids couldn't solve exactly what I'm showing you here on the screen, and they would solve it incorrectly. So we want to solve this formula. Again, it's a made up one right now, guys, and we want to solve it for G. Okay, so the mistake, is everybody listening? The wrong way to do it is everybody says, oh, just divide both sides by D and I'm good. If you divide both sides by D, you've left G in the denominator. You did not solve for G, you solved for 1 over G. I hope you heard that, because no matter what I do every year, quite a few people will still do that. So I'm going to give you a way that I look at it. Instead of looking at it this way, what I do is I put that C over 1. So I now look at this formula like it's a proportion, a ratio equaling a ratio. And when you solve a proportion, do you remember that you multiply the cross? Remember cross products? You multiply the corners. So do you see you would multiply C times G equals 1 times D. That's how we solve a proportion. So CG equals 1 times D. I just wrote it the other way. And 1 times D is just D. And you might say, well, Mrs. Woodruff, you didn't solve for G, but now I can very easily. Now, if I divide both sides by C, I will leave G where, in the numerator, G over 1, and that would be the solution. If you make the mistake that I said at the beginning, you will have C over D, not D over C. You will have it flipped by mistake. So I just want to make that clear, that if you see a formula that looks kind of like a fraction equaling something, make them both fractions, or if they are both fractions, think about solving it as a proportion. Do the cross products, and you kind of get rid of that fraction looking thing. Again, anytime we can clear those fractions, we have a clearer view of what to do. Okay, so a minute ago I said I would do the distributive both ways. I would show you why there's a more efficient way versus another way that can get more complicated. So I'm going to do this one my way, the fast way first, and then I will do the distributive property and show you why it is more inefficient. It's a simpler problem than the one we were looking at a minute ago with the trapezoid. So I would say, instead of doing the distributive property, because you're multiplying by 2, divide both sides by 2. That would be my first step. And you end up with a 1 here. So you just end up with T plus R equaling 5/2. So when you divide by the 2, you get rid of that number out in front of the distributive, what looks like a distributive property really quickly. I'm solving for T. That's what this means up here. So if you're looking at the worksheet later and you see the semicolon T, it means solve this formula for T, okay? So now to solve it for T, subtract R, I'm done from both sides, right? So now let me show you what would happen if you did the distributive property. You will get the same answer, okay? But it's an inefficient way to do it. So you'll multiply, and what you've done is you wanted the T by itself, but it was by itself in there. I mean, it had a coefficient of 1, but now it has a coefficient of 2. Now you would subtract 2R from both sides. And now you have to divide by 2. And that's the inefficient step, because you multiplied 2 a few steps ago, and then you divide it out 2 steps later. So that is inefficient to do it one way and then undo it 2 minutes later, okay? So your final answer here would be T equals 5 minus 2R over 2. These are the same answer. I want you to see this common denominator? Imagine if you split these two over the common denominator. Do you see the 5 over 2? Look at it. Do you see the minus? And do you see the 2 over 2? 2 over 2 would be 1R. So these are the same answer. This is the better way to write it over here, to be honest. But you're doing a step and then undoing a step. You might say it doesn't look like a big deal there, but man, if you do it with this one, it just creates a mess. So the best thing to do is to get rid of this by, getting it over to the other side rather than doing the distributive property. Okay, we've come to that place now where it's your turn to try. So we're going to start with an easy one. Number one, first of all, do you recognize that formula? It would be the area of a rectangle, right? So you're going to solve the area of a rectangle for the width, for the W. And over here, this is a made-up formula, and I'm asking you to solve it for T. Okay, so pause the video, do the first one, do the second one, come back, and we'll see how you did. Okay, so to solve for the W, since you are multiplying, you would divide. That's not a 1, that's an L. Since you are multiplying by L, to move it, you would divide by L. And area divided by length equals width. That was not a big shocker, was it? Okay, now over here, I want to solve for T. Notice the first thing I did is I put this C over 1, so I can just see everything as a proportion. I'm going to multiply the C times the V and the 1 times the W plus T, and that's the formula I'm looking at. And now to solve for T, I just subtract W. And there is my newly arranged formula solved for a different variable. Got one more for you to try. It is a real mathematical formula, not made up. And the first thing I'm going to ask you is, do you recognize it? So stop and ask, what is this the formula for? Okay, first of all, we know it's a volume. Second thing, I see pi r squared in there. That's a circle. That's the area of a circle. There's the circle times h. If it had been pi r squared h, that's a cylinder, but I took a third of it. This is the volume of a cone. Now remember that the semicolon h, it's asking you to solve it for h. Okay, so pause the video and see how you do with this one. Okay, let's see if we got it. I would have started by multiplying both sides by 3 to clear this fraction. And when I multiply both sides by 3, I end up with 3v equals pi r squared h. I now want to solve this for h, and watch the magic happen. If you went and divided by pi and then by r squared, and you ended up with this gosh awful complex fraction, which you cannot leave it that way, the easiest way to do it is realize that h is being multiplied by pi r squared, and in one step, divide both sides by the pi r squared. Oh, by the way, that's the area of a circle. So your final formula, because you've got pi over pi is 1 and r squared over r squared is 1, so you have h by itself, you basically take 3 times the volume and divide it by pi r squared, and you get the height of the cone. So that is a quick lesson on transforming formulas. Like I said, you are going to have a worksheet, but don't be surprised. The worksheet doesn't match our book. It's not in our textbook, so if you go trying to find this in the textbook, it will not be in there. So give it a go. We're going to take formula, we're going to take a literal equation, and we are going to solve it for a different variable. Remember that the semicolon after that's telling you which variable to solve for. So guys, I hope you have a great day. Have fun solving and transforming formulas.